This is our power inverter. I have to undo those two screws and they reveal capacitor that is being blown. Here you can see that it's vented. Here is a close-up. Exploded very nicely. We should now try to remove it and replace. And we are going to see whether it fixes our problem, because we've got absolutely no idea. You have to make sure that we've got the proper polarity. Did I undo it correctly? Yes. We need to grab an extraction tool and let's take a look. The capacitor was a 1000 microfarad at 16 volt. Let me try to find a replacement and we are going to check it again. I've got better quality, low ESR, 1000 microfarad at 25 volts. We can always go with a higher voltage rating. This is absolutely no problem. So let me insert it correctly with a proper polarity. And looks like it's going to be working just fine. Absolutely beautiful. We've got a great job. That looks very nice. So this is our first issue that I was able to see. Okay, and we are ready to power it on. I'm going to move the fan and I'm going to plug it into my power supply. That very unpleasant sound is telling me that we've got a short somewhere and we need to find it. Let's check the diode. The diode looks okay. We've got 0.6 volt forward drop. In the reverse polarity we read nothing, so it is most likely okay. Now the question is what to do. We can hear the low voltage alarm, and that means the logic is working, so it is not a totally 100% short. The low voltage side, if there will be a dead short, then the logic should not be working, so I would assume that's going to be on the H bridge, and that's the reason why electronic is detecting overload, the voltage drop, and self shutting it off and repeating the cycle, as you can hear when I plug it in. So it's cycling on off and shutting down. Here you can see the LED. It's trying to restart. We can try to feel something. Of course, now it's off. It's hard to tell. Let's start with the low voltage side, but I'm not think that's going to be our problem. We need to make sure that we've got insulation pads, because we've got a common heatsink. And let's try to undo it. Let's try to check our MOSFETs. We start from that one. We grab our components tester. And most likely the measurements are going to be more than enough to tell whether it is operational. Sometimes on the high voltage side you can have a problem, but this is looking okay. So we have to put it back. So maybe my assumption was correct. Looks okay. So most likely there will be a problem with the high voltage side. This is what we've got over here. Okay, and now we should be able to pull all of them, and we can start doing our tests. Just like that, they go really nicely. And that one is working just fine. The next one, that one is faulty, as you can see. We've got a short circuit between green and blue. This is the IRF 730, pretty common. I should have one in my assortment. From box of my replacement MOSFETs, I managed to find the same model. It is operational, and of course it is exactly the same model, the IRF 730. And we would have to transfer not only the protective film but the center leg heat shrink. I'm pretty sure they put it for a very specific reason, so we are going to transfer it. That is going to be perfect. Absolutely beautiful. We have to transfer the heat shrink silicone pad, and we put it into the original location. Just like that. I'm going to make sure it is correctly, but we are going to check other MOSFETs because they could possibly fail in pairs. And we've got another broken one. We've got a dead short circuit. Absolutely not good. And let's check the last one. We are checking the last one, and it's also short. So Houston, we've got a problem because I have to replace those two, and I'm pretty sure I do not have them. So I will have to order and wait. So this is a bummer. After a lot of diggings, I managed to find those two IRF 730. One of them looks like it's being used, the second one looks like a brand new, and we are going to put them, and we are going to take a look whether it's resolved our issue. So here is our board. We have to transfer the isolator. That one we can put as is because we've got the shielding on the leg. On that one I added a leg, and we are going also transfer the insulator. Let's check the case from shorts. So we are measuring the heatsink and the plate, and we've got absolutely nothing. If we touch the metal part, then we are going to hear the buzz, and this is what we want. Here we do not have connection, so the insulation is okay. Let's solder our MOSFETs. They look okay. I make sure that we've got a nice thick traces to carry more current. Do we have everything soldered in place? And in my personal opinion, yes. I do not see any shorts. That side is also soldered, so I'm pretty sure we can try to power it on. I just discovered something pretty horrific. Inside the case, I found a rattling piece of wire, a jumper wire, and it belongs under those two MOSFETs. Here you can see there is a link. I'm not sure if you can see exactly the same one, and there is missing. I don't know if that was me when I was desoldering it and it just fell off, or that happened when the MOSFET overheated, when there was a short, and this is where when it fell off. So I'm going to try to put it back. Okay, the link soldered in place. It was too clean, so in my opinion I sucked the solder and it cleared the pad and it just fell off. So most likely that was my fault. And let's try to make a test. The first one we are going to do with a power supply because I don't want to blow anything. So let's connect it. Let me set the voltage. 14 volts, 5 amp limit current. And we plug it in. The safety glasses are on. And nothing happened. But maybe the inverter is off. Let me turn it on. And it's working. 160 milliamp. This is what it's pulling. We do not have short. Let's try to measure the output voltage. Let's go to the true RMS and let's just measure the socket. And let's take a look what we've got. Since it is a modified sine wave, you should use a true RMS meter to get a real value. If you are going to not use a true RMS meter, you might get something totally off. But here we've got an absolutely beautiful value. Since we removed the short, we can now connect it to the battery. I'm going to grab a SLA battery and we are going to test it under load. because I was afraid to plug it into the battery because we had a short and we could blow it much more. Okay, and let's grab that beautiful lamp that I'm going to put on my Victron Energy panel. So I'm going to get a nice set, and it is a 75 watts. And maybe not to blow it, I'm going to turn the inverter off, and I'm going to touch the leads, and I will allow it to slow start. So let's take a look. And it looking perfect. It's telling me that we've got a too low voltage, but it is okay. The fan is spinning and everything is fine. Let me remove the load. The low battery warning deactivated, and the inverter is still working. So just for test, let me touch it like that. If it's going to blow, then it will blow. It's working perfect. Fan starting. We've got a good fix. So here is what we replaced to make it working: the IRF730 MOSFETs plus that exploded capacitor. It is pretty interesting because it's like doesn't make really sense to me because it have a reverse polarity protection. That's when usually a capacitor blow like this, and at the input side, because the high voltage after the chopper is okay. So yeah, quite interesting. That was a common problem. I have them in my drawer, and we've got a good fix. As you can see, everything is working fine. The AC lamp is glowing. I replaced the bulb because I don't want to hear that constant beeping sound. If we take a look, the battery is not fully charged, and this is the reason. But we've got a good fix. I'm going to order replacement SLA battery, and we are going to get another video about replacing it. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.